Trig Free College Math, trig functions. In this video, this is our introduction video back into the world of trigonometry for our course. So the next probably, I don't know, 10 videos are going to be about trigonometry. Today is kind of refreshing our memories on some of the more basic trig things that you actually did in probably like 9th grade or 10th grade. Um, but they're foundational type of things, and so we really need to make sure we know these things well, like basic functions of sine, cosine, and tangent, and what sides they are the ratios for, and Pythagorean theorem, and how to solve for an angle or a side using a calculator, and stuff like that. So let's see. The first thing here is asking which of these trig equations is valid for what we see here. Now, first of all, just look at a couple of things about this. We have angles A, B, and C. Notice that lowercase a is opposite angle A. And that is not a coincidence. That's by design, that we use capital letters to represent angles and lowercase letters to represent the sides that are opposite those angles. And we're going to be using a lot of terms like opposite, adjacent, hypotenuse. Now, C is our right angle here, and I think it probably mentions that here. C is the right angle. So side C, which is opposite angle B, is called the hypotenuse, and that doesn't change. That is its name no matter what. The opposite and adjacent sides are angle dependent, meaning depending on what angle you're using as perspective, it changes. So if I'm talking about angle A, for example, side A, which is across from it, would be opposite, and this other side, B, would be called the adjacent side. Now, if I switch my focus to angle B, then this side B becomes the opposite side, and angle A over here is the adjacent side. So opposite and adjacent flip-flop when you flip-flop between the two acute complementary angles over here. And that actually is part of a concept called cofunctions, which we will get more into another time. So, okay, let's take a look at this problem. So we want to look at these each one at a time, but we do need to remember what each function stands for. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent's opposite over adjacent. And so we use SOHCAHTOA to remember that, but this needs to really just be second nature to you at this point. Now you maybe haven't thought about SOHCAHTOA and trig for a couple of months now, so hopefully it's going to come back quick to you. But by the end of this lesson, this has to really just be second nature. So let's look at each of these trig functions for us here. Cosine A. So cosine of A. Cosine from angle A, this is my opposite side, and this is my adjacent side, and this is my hypotenuse. So cosine is adjacent over hypotenuse. That would be A over C. I'm sorry, that would be adjacent. So B over C, not C over B. So this is upside down, so that is not a true statement. Tangent of A is opposite over adjacent, so that'd be A over B, not B over A. Again, upside down, so false. Sine A opposite over hypotenuse is A over C. That is correct. And let's just look at this last one. Cosine B. Now, this would no longer be adjacent. It would be opposite. And this would no longer be opposite. It would be adjacent. So cosine B would be adjacent over hypotenuse A over C, not A over B. So C is the valid function here. This next question is very similar, saying which of these could be used to solve for x. And again, it's just which of these are true statements based off of this. Now notice that we only have two sides here, and instead of labeling all three angles, they give us one angle measurement. And so this is the angle we're using to label our sides as opposite, adjacent, hypotenuse, so on. The hypotenuse is the hypotenuse no matter what angle you're using. It's across from our right angle, so x is our hypotenuse. And from this angle 20's perspective, this would be the opposite side, and there's nothing there. And that would mean that 12 here is adjacent. So we're limited to one trig function because we have terms for adjacent and hypotenuse. Adjacent and hypotenuse is only when you're dealing with cosine. So we're looking for a cos function, like these three. And it would be cos 20 because all trig functions set up like this, with a function followed by an angle. Remember the theta symbol? That's the symbol we use to represent angles. So function angle equals ratio. And so this would be cosine 20 equals adjacent over hypotenuse. Cosine 20 equals adjacent over hypotenuse. Function angle equals ratio. This is an important concept right here, how everything is set up. And we saw that with these too. Like this is saying sine of angle A is your opposite over your hypotenuse, which are A and C. So every trig function sets up that way. And that's how we can, solve this now. This problem doesn't want us to solve for x, but we could. We could put this over 1 and cross multiply. So let's actually do that real quick. If we were to cross multiply this, x times cos 20 you want to think of as x times cos 20. Cos 20 is one thing. You don't multiply just by the 20 or the cos. It's cos 20. So x times cos 20, and 12 times 1 is 12. I can then get x alone by dividing by cos 20, divide by cos 20. And so this is what I'm going to type into my calculator now to get my value for x. I apologize, this computer that I'm using doesn't have the calculator I could pull up on the screen, so I'm going to be using a calculator to the side for this. But I'll tell you what I'm typing in. I'm typing in 12 divided by cosine of 20. And my calculator is telling me 12.77, which I'll just round to 13. Now the question will probably tell you what to round to. We're doing a little extra here. And so it's about 13. Now, if your calculator is not giving you that answer, the first thing you need to check is make sure that your calculator is on degrees, not radians. This is a 20 degrees. We're working with degrees, not radians. We will talk about radians, but in another video. Okay, this one wants you to solve for x to the nearest integer. So it's kind of like they set up a problem like what we did here. They just want us to do the cross multiplication. So let's do that. 30 times sine 38. And remember, that's 30 times sine 38, not 30 times 38 and the sine of that. You actually need to type into your calculator. 30 times sine 38 equals x times 1 is x. And so you don't have to divide here. When you're solving for sides and cross multiplying, sometimes when x is across from the 1, it's just multiply these and you're done. When x is not across from the 1, like in this case, then you have that extra step of division. So it could go a couple of ways. So again, I'm going to type this into my calculator on the side. 30 times sine 38. 30 times sine 38 equals 18.469, so on, so on, so on. So the nearest integer would be 18. So x is approximately 18, and I'm making these equal signs squiggly on purpose because that stands for approximately, because x is not equal to 18, it's approximately 18 when I round. And so that is that. Okay, and so next problem here. This question wants to find the measure of angle K. So where these last two problems were finding side lengths, this one's finding an angle measure. And it's set up the same, where we first need to determine a function of some angle and set it equal to a ratio. And so that would be, what function are we? Well, from this angle's perspective, opposite would be here, not there. Adjacent would be here, and my hypotenuse is here. So once again, I'm dealing with adjacent hypotenuse, so cosine. So cosine is the function, k is the unknown angle, and its ratio is 5/6. Now this is different than these two questions, because notice where x is. X for here, when you're finding a side, is part of the ratio. It's one of the missing numbers in the fraction. Here, we're not dealing with x, we're dealing with k, but we're finding an angle. So we do not cross multiply when you're finding an angle. Instead, you have to use what we call inverse functions. And so we can change function theta equals ratio into inverse function. Remember, the inverse symbol is like a -1 looking exponent. That stands for inverse function ratio equals zeta. So these two equations go together, and they both need to be known. The function angle to ratio, well, inverse function ratio equals angle. And that's what we're going to do here, is I'm going to change this cos k equals 5/6 to inverse cosine 5/6 equals k. And on my calculator, we get the inverse cosine by hitting the second cosine key. So I'm going to do this on my calculator on the side here. So that would be inverse cosine 5 divided by 6 comes out to be 33.5577, so on, so on, so on. And then you would need to type in a DMS key for degrees, minutes, seconds. And I want to show that to you. So I'll show it to you in class how to do DMS, how to turn this into degrees, minutes, seconds. And it works out the answer is A. But I'll explain that in more detail in class. But you should be able to be getting the 33.55. So let me write down 33.5573. Okay, but converting that to degrees, minutes, seconds involves a DMS key. But I'll tell you about that tomorrow in class. Okay? And we'll do this next one tomorrow in class also. All right, see ya.